In this video, I'm going to talk about finding average of a function. However, before that, let me define the basic average that pretty much everyone knows. So let's say you have a bunch of numbers, 0, -1, 2, 5, 3. So you have 5 numbers here. To find the average of these 5 numbers, what do? You add these 5 numbers and divide it by 5. So I'm going to divide it by 5. So what is the sum of these 5 numbers? 5 plus 3, 8, plus 2, 10, minus 1 is 9. So your sum of these numbers is 9, and if you divide it by 5, is going to be 1.8. That's how you find average. However, let's take a slightly different example where things are not so discrete. So let's say you are following a stock, okay? And the stock price changes. So this is how stock is behaving. Something like this. So this is stock price. So let's say you want to find the average stock price, say, let's say going from 0 to 10 in the 10 minutes, okay? So you're going to divide this interval of 10 minutes into 1, 2, 3, and all the way up to 10. So what do? You find the price of the stock at that time at 1 minute, 2 minutes, 3 minutes. So you'll get 10 numbers and you add them and divide them by 10. That's how you'd get it. However, let's say we want to find the average at a smaller window of time, not 1 minute, but smaller. Because see, if you look at this function or the stock price, which is changing instantaneously, every moment it's changing, but you're taking it at windows. So if you want to find better approximation to this average price, you probably want to make this window smaller. You want to make the window smaller. So let's say we have a window, we call it delta x, okay? As you can see, I'm going towards calculus. So I'm going to take a small window, delta x, and over this window, I'm going to find the stock price. Which is a function. So my stock price is f of x sub I. So delta x is some ith interval. So I divide the interval from 0 to 10 into smaller subintervals, and I call them delta x. Each of these subintervals are the same in length, delta x. So in this window, I kind of take any random number in this window of delta x and just find the value of the function f of x sub I star. Now, how many such intervals I have or subintervals I have? Let's say we have n of them. So to find the average, okay, I'm going to have to add all of these guys from I is equal to 1 to n f of x sub I star. So I have n intervals or n deltas, okay, n delta x's. So I have to divide it by n. So I have n numbers from n different delta x intervals, and I add them up and divide it by n, the total number of subintervals that I am considering. This is exactly like this, finding the average, just the familiar discrete case average. I'm just extending it to smaller windows, so no problem there. Now, if this is my A, and this point is my B, then that delta x is equal to B minus A divided by n. Or if I solve for n, I get n is equal to b minus a over delta x. So in this average, what I call f sub ave for average of the function. Okay, this is an approximation. So technically, I could say kind of approximately. because this is not the true average but an approximation, and this approximation gets better and better if you make the window delta x smaller and smaller. Now what I'm going to do, I'm going to take my f sub average and I'm going to approximate it by summation I is equal to 1 to n f of x sub I star, all of it divided by, instead of n, I'm going to just use this, b minus a divided by delta x, which will give me f sub AVE approximately 1 over b minus a times summation I is equal to 1 to n f of x sub I star times delta x. You can see things are coming together, right? Now to find the true average, okay, f average, I'm going to have to take limit 1 over b minus a. b minus a is a constant, so it's not going to be impacted by the limit. So limit n approaches infinity, summation I is equal to 1 to n f of x sub I star delta x, which by the way is nothing but f sub average is equal to 1 over b minus a integral a to b f of x dx. This, by the way, is the official definition of average of a function over some interval. Let me now do something informal with this integral. So let's say the integral a to b f of x dx, which we are assuming that it exists. So remember, there is an antiderivative of f, right, such that f prime is equal to f. And also this integral, by the fundamental theorem of calculus part 2, this integral is nothing but f of b minus f of a. So this integral will be this. So now if I plug it into this, I'm going to get f average is equal to 1 over b minus a times f of b, uppercase f of b minus f of a. By the way, this is kind of exactly the mean value theorem, isn't it? F average is equal to f of b minus f of a divided by b minus a. So this informally shows that this is kind of like the mean value theorem that you are used to. Of course, we have to make the assumption that f is continuous on the closed interval and differentiable in the open interval. All of this are kind of assumed. So by fundamental theorem of calculus and by the mean value theorem, we will have to say that this is nothing but f of c. Technically f prime of c, right? But f prime is f, so f of c. So now here is a different version of the theorem, which is this integral a to b. So integral a to b f of x dx is equal to f of c times b minus a. To help you understand the concept, let me give you an example. Examples are better. It helps you see things. Let's say you have a function f of x is equal to e to the power negative x, and you want to find the average of this function maybe on the interval negative 1 to 1. So we want to find f average, okay, on the interval negative 1 to 1. So it's going to be 1 over b minus a integral a to b f of x dx. So my f sub average is going to be 1 over b minus a. My b is 1 and a is negative 1. Okay, so I'm trying to find the integral between average between negative 1 and positive 1. So that's going to give me from negative 1 to 1 e to the power negative x dx. And that is going to be, by the way, equal to 1 over 2. This is going to give you 2 in the denominator. And the integral is going to be negative e to the power negative x. And I need to evaluate it from negative 1 to 1. So that's going to be negative 1/2 times e to the power negative 1 when I plug in 1 minus, and minus is going to make it plus, 1/2 times e to the power negative 1. Okay, so that's going to give me negative 1 over 2e plus e to the power negative times negative 1 is positive 1, e to the power 1 is 1 over 2, and I can multiply and divide it by e to make the common denominator. So that's going to give me e times e is equal to e square minus 1 divided by 2e. So that's going to be the average of this function in the interval. Now I can take this idea and expand it a little bit. So we know f sub average is equal to f of c. So which tells me that this must be equal to f of c. But f of c, by the way, is e to the power negative c. So that tells me e square minus 1 over 2e must be equal to e to the power negative c. But e to the power negative c is the same as 1 over e to the power c, which is going to be equal to e square minus 1 over 2e. And if I take the reciprocal, I'm going to get e to the power c is equal to 2e divided by e square minus 1. At this point, I can go ahead and apply the natural log to both sides. This is an exponent, so I can bring it up front. So that's going to give me c times ln of e, but ln of e is going to be just 1 because e and ln are inverses of each other. And then using the quotient rule, I could simplify it to ln of 2e minus ln of e square minus 1. Now this is going to be 1, so that's going to give me c is equal to, this will be ln of e plus ln of 2, but ln of e is 1, so 1 plus ln of 2 minus ln of e square minus 1. So at this point where the function will achieve its average, so if you plug in this value into e to the power negative x, then you're going to get the average value. So just to summarize, what did we do? We have done a lot. We have defined the average for a function over some interval. Then we took that idea and kind of connected it with the mean value theorem. Then we have done an example of it and tried to find the point C where f of c achieves the average. We tried to find the point C, which in this case was this. I hope that this discussion was helpful. Thank you very much.